Hello and welcome to Alchemy Design. I wanted to talk a little bit about support material, and this is the solution I came up with to deal with the cost of support removal systems. So, if you're familiar with using Makerbot, um, I think Ultimaker, others obviously Stratasys, a lot of them come with dual heads, and they use support material, and it's dissolvable support material. So most of us are familiar with PVA, kind of a translucent, starchy, dissolvable material. It takes a while. You're constantly removing, changing water, and hot water works best in hot water. You got to agitate it. Time consuming. I actually don't get great print quality from it either, so I'm not overly happy with it, but you have to use it with some materials, um, like PLA. Then there's RapidRinse. This is a Makerbot material. Actually dissolves really well in just regular water, lukewarm water, hot water. Much quicker, better print quality, but still it's kind of a pain to work with as well. I mean, but it's good material. Only works with one material though, and that's ABS-R. So it's very specific. It'd be nice to see that with other materials if it could be used sometime. And then the other option that's out there is SR30, which is and I don't have any here, but it's a Stratasys material that's dissolvable as well, but it does require a special, I think they call it EcoWash or something. I'll show a picture of it, that you can get from the Stratasys website or the Makerbot website. I've used that material. It's really great material, support material for really good quality prints. It works on a bunch of different materials and can be used on the Makerbot and Stratasys, but I don't really know anywhere else that it's possibly used right now. Really good material, but you do need to have that eco wash, and high temperatures is even better when it comes to dissolving it in water. So with that, let's talk a little bit about that. So the current solution that's really out there is this item right here. It is a $3,500 wash system, and it's quite expensive. And yet you've got to think about the guts of it. It's probably pretty simple. It has a heater in it, it has a pump in it, it has stainless steel interior. It can get pretty hot. It can get up to 80 degrees Celsius or 90 degrees Celsius. I don't quite remember. So some of those hot temperatures are nice, but they're not always necessary. You can go with lower temperatures. It just takes a little bit longer. And obviously higher temperature materials take a little while. So I want to talk a little bit about what I did for a solution, because I kind of got tired of constantly putting things in buckets and changing out water and going and moving them around. And so I thought, hey, why can't I just build one of these? So I'm going to show you what that is right now. Then I'll go show you an actual video of the finished product. All right, so this is basically my design. It is all off-the-shelf components other than some 3D printed parts and some sheet metal, stainless steel sheet metal parts. An important part of this build is you want everything as much as possible to be stainless steel, because it is in water, and potentially if you use SR30, that detergent could be somewhat corrosive. So it's very basic. This is a Sterilite bin that you can get from Walmart. It's been modified with some components, with a ball valve to drain it. The sheet metal parts that I designed, with some support base and a diffuser and a place to mount a pump and a place to mount a bucket heater and all those necessary components. And basically a tube running to the diffuser to the pump. So pretty straightforward, the concept of it, although it took quite a few iterations of design. You'll see my file up here. This is version 21. This is an updated version. So there's another one that had like 60 or some iterations. But so this is what I made. I've tested it. I've used it. It works pretty well on PVA and RapidRinse. Have not done it on SR30. I imagine it'll work just fine. It'll just take longer. because with this design, I can only go to 42 degrees Celsius. That pump is rated only at 35, so I don't really want to go up higher than really 42. I'm sure it can do a little higher still, but the heating thermostat that controls the bucket heater, I have one that will go to the 40 degrees Celsius. I have another one that'll go higher, but right off the bat, I noticed that one just plugging it in at a low, even at a low temperature, the wire got really hot. So you really need a heavy gauge. The pump does a good job of just kind of moving the water around. It's not like creating a bunch of waves or anything. I could go with a stronger pump to do even more, or even maybe change the design of how it shoots it out. But this was all contained, and it is adequate for the job. I think I put a RapidRinse ABS in there, and it was dissolved probably in a couple hours, so not too bad. Anyway, we're going to go just take a look at it and walk through it, and I'll leave some information in the description and things like that. The whole bill material, all the files used to do the sheet metal and the 3D printing and the instructions and all that are going to be available on my Etsy site if you're interested. Total cost for putting this together plus the instructions and stuff that I provide is $700, which is a far cry less than the $3,500 for the other products that's out there. So this would be, if you're a small shop, really inexpensive to do. If you're a school, this would be a great project for the class. If you're a small manufacturer and you want a solution, this is a great way just to do a project maybe with an intern, things like that. So anyway, let's go take a look. All right, let's go check what we got. Don't mind the mess. So, this was my solution for a support removal system. Apart. Put that in there. Go through it in a little bit more detail. Max pump. Temperature control set at 42. Current water temp 27.6. Max I can go is 42. So on this. All right. So this was my solution to this. This is just a bin with a gasket on it. You get them at Walmart. A thermal regulator, thermostat, pump control. What you see there is a bucket heater. Tried a different pump at one time, not quite strong enough. Even the one in here is a little not quite strong enough, but it does the job. I could upsize that. I tried a different, initially I wanted to go a little higher temperature. Was going to use a different thermostat, but this cord's not really thick enough. It gets really hot, so I don't trust it. So I went back to the other one, which has a nice thick cord. And 42 degrees Celsius is pretty good for most things. It'll work good with PVA. It'll work good with RapidRinse. I haven't tried it on SR30 yet. It'll probably work okay. It'll just take longer. I would say SR30 is probably a more superior support material than the other two, but it's more expensive. You can only use it with certain materials, of course. Same with RapidRinse. And you got to have a special detergent that you add to dissolve, so you got to deal with that as well. So I am not using that right now. So anyway, like I said, it is just a Sterilite bin that I have come up with different components
There is a divider in there that's holding everything in behind it. A diffuser screen, whether I need that or not, I don't know. A base. I'll try to get a look at the back. These are pass-through fittings. This allows you to pass the wires through, but yet still attach that divider in the system to the back of the bin. Before I go to the back, I guess. Ball valve and a way to empty it. And the guts of the back, you can't necessarily see everything, but there's a pump there. I don't remember the size this is, 12 gallons per minute maybe, I can't remember. Hose that goes to the diffuser and out the front to just help rotate the water around a little bit. You can see it's moving. And then there's kind of a heat shield on the bottom and around the back, around the heating element, so it doesn't get this plastic too hot, so it helps deflect some of that. Because that thing kicks on, it gets pretty hot just to get it up to temperature. So pretty straightforward, although it took a lot of time to design the components. But as I said earlier, the other option is a system that Stratasys uses that costs $3,500. So all in, minus the stuff that I tried out, and you're gonna spend probably, I don't know, it's like $475 or something like that. I have it figured out for the components. However, a little bit more than that, because if you want my drawings and my files to do the sheet metal and 3D print all the parts, and then as well as the bill of material and assembly instructions, I'm going to be selling that on Etsy. So I'll put the link below so you can get a link to that. And you can pretty much get all those files, follow the links, go to the hardware store, whatever you need. Use whoever you want to do sheet metal yourself or third party. So works pretty good. It's a lot better than putting your stuff in a bucket of hot water and having to constantly change that water all the time and waste that water all the time. So I'm happy with it. It does the job. Things I said, like I would improve maybe a larger pump, and I'd like to go where I could get to like 50 or 60 degrees Celsius, but pumps are only really rated for 35, 40 degrees in the water, but I think they would last a little longer. Could try that out. And yeah, other than that, hopefully this will help some of you people that are using support material like RapidRinse or PVA or SR30 and don't want to drop the $3,500 for a fancy tank that pretty much is these components, other than it's in probably a stainless steel container, and then try to buy a bunch of plastic. So anyway, have any questions, comments, leave them down below and I'll answer them as soon as possible. And then please leave a like or subscribe to my channel. That would be useful to help get this out to other people who maybe have Makerbot systems that use a lot of these materials, or Stratasys systems that use a lot of these materials, or if they're using PVA material on some other things. And with that, take care, and hopefully you might find this useful.